Mr. Charita, are you there? Mr. Charit, can you hear me? Mr. Charita, are you there?
Yes, madam. Yes.
Okay. Because I think Mr. Charita, are you
Yes,
there?
madam. Hello.
Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charita, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why
Hello.
is it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why is
Hello.
it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why
Hello.
is it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why is
Hello.
it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why is
Hello.
it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why is
Hello.
it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think Mr.
Why is it
Charita, are you
Yes,
there?
madam.
Why is
Hello.
it repeating, Charit? Okay. No, I thought I'm in a
Mr.
wrong
Charit.
session or something because there are
Hear
only
me?
3 participants with still only Naomi has joined, I think. Mr. Charit, are you
Yes,
there?
madam. Yes.
Okay. Because I think
Veramente con Hello, Chandri, can you hear me?
Yes, Professor, we can
Okay,
hear
right.
you.
Okay,
Yeah,
right.
yeah.
That's fine. Okay.
We will start at 1:15, Professor.
I think new link and all link going to be same, I think. The previous link and the what you have
Yeah,
set
yeah,
the updated version.
maybe. Yeah,
Yeah, I
only
think.
some things changed.
Okay. Only time change. I think earlier it was 1 o'clock was no, 12:45. Now it's
Yeah,
1:50.
yeah. Earlier it was 12:45. Yes.
That's
Now it's Ms. Kalpani, can you kindly rename with the abstract number? Please rename yourself. A very good afternoon to all of you. I'm Chandani Navaratna, the theme convener for physical sciences. I consider it as a privilege to introduce our chairperson for this session, Professor VPS Pereira. He is a professor attached to the Department of Physics of the Open University of Sri Lanka. We are at a time highly dependent on the internet. So to assure everything runs smoothly, we have a co-chairperson for this session, Engineer Rajit Priyankar. There are 7 presentations lined up for this session. Without taking more of your time, let me invite Professor Susira Pereira to take over. Over to you, Professor Susira.
Thank you very much, Dr. Chandani. Good afternoon, everyone, and welcome to the parallel online session 4 of ours 2021 under Physical Science team. As Dr. Chandani mentioned, in this session, we have 7 presentations lined up. Each presentation is about 10 minutes and 5 minutes are allocated for questions. After the presentations, the presenter will appear online to answer the questions raised by the audience. And I kindly request all of you to keep your mics muted during the presentation. So with that, we can move to the presentations. The first presentation is synthesis of pyrrole derivatives with pendant anthracene groups. The author is S.D. Pereira, and the paper will be presented by S.D. Pereira.
The title of my presentation is Synthesis of Pyrrole Derivatives with Pendant Anthracene Groups. We have synthesized 2 derivatives, one with 1 cyanoanthracene unit and the other one with 2 cyanoanthracene units. We call this compound compound 7 and this is compound 8. The outline of my presentation is pyrrole and polypyrrole derivatives, examples of pyrrole derivatives with redox centers or electroactive groups, some of their applications, and synthesis of the target molecules, electrochemistry of the compound 7. In fact, we found the compound is not very soluble in acid nitrite, so we couldn't conduct any electrochemistry on that. Pyrrole and polypyrrole. If you take pyrrole molecule, you can polymerize to give polypyrrole as shown here. Polymerization can be achieved in 2 ways. First one, the chemical method using oxidating agents such as iron trichloride. There are many more oxidating agents possible. And electropolymerization, or we call it oxidative polymerization, by keeping the electrode potential, the anodic potential at about 1.2 volts. Thereby you can prepare modified electrodes. And pyrrole molecules are oxidized and are linked by 2 and 5 positions. You can see 2 and 5 positions, they are linked to make the polymer. So if you want to introduce any electroactive groups, you have to introduce them onto 3 and 4 position, or in this case like 1 position, the nitrogen. So I have given you some, I can show you some of the literature work, and here it is the electroactive group is anthraquinone, or we can have the benzoquinone, or naphthoquinone, or pyromeltimide. And here we can have the ferrocene as well. But you can see now here it is attached to carbon, and in these cases the electroactive group is attached to nitrogen, position 1. And in this case you can see it's attached to nitrogen and here carbon. In our work we have decided to introduce anthracene, and because it is a photoactive molecule and it under UV light it fluoresces. However, there's a major problem. It's that its reduction potential is quite negative. So we introduce the cyano group onto the moiety to make it more positive. Thereby, you can achieve the potential, redox potential above -1.5 volts. And some of the importance and application I have given here, and is a method of fixing redox centers to the electrode surface. These films are conductive material. They can act as electrocatalyst. And this is one way of making chiral electrodes. You can attach chiral molecule to electrode surface and they have a chiral electrode. They can do some chiral synthesis. And this material can be used as a battery material. The synthetic group is given in this slide, and we started with methyl anthracene, which you can purchase, and Wilsmeyer formylation of this compound 1 using DMF and phosphorus oxychloride. We can produce the aldehyde groups, and I have shown you the NMR spectroscopic data, some of them. The methyl protons appear at 3.1.6 ppm, and the aldehyde proton about 11.31 ppm. And all these compounds are yellow color, and in this case we can have a good yield about 75%. The IR value which shown here 1655 wave numbers. Aldehyde group can be converted into the oxime group in 88% yield using hydroxylamine, and the chemical shifts are very similar here for the methyl group, and very importantly that oxime OH proton appear around 7.82, and if you have a D2O shake you can see disappearance of that peak. So oxime can be converted into the cyano group by dehydrogenation using acidic anhydride in very good yield, and the IR value shows the presence of the cyano group 2210 wave numbers. And finally, we brominate the methyl group using N-bromosuccinamide, about 6% yield, and the chemical shift of the CH2 group is about 5.48 ppm. Now we got to prepare the pyrrole part, and diethyl aminopyrrole, and which can be achieved using commercially available furan. And here we did the electrochemical synthesis using keeping a potential at a positive in the presence of methanol. You can make this dimethoxy dihydrofuran with condensation with ethylene diamine. You make the compound 6. So linking these two components can be achieved using potassium carbonate. So dehydrobromination will give you two products here. One is the secondary amine, another one is the tertiary amine, contain two cyanoanthracene units. The chemical sheet for these protons here 4.59 ppm. There are four of them here, and we can easily see the mass values. Here the lower mass value 325 for the parent ion, and here 540 for the parent ion, and IR value quite okay for the cyano groups. Now we'll look at the electrochemistry of the compound 7, cyclic voltammetry was done. Cyclic voltagram of this compound 7 in a 2 millimolar solution in acetonitrile containing the electrolyte tetrapropyl ammonium perchlorate showed a reversible, as expected, reversible voltogram, and the redox potential is minus 1.47 in figure 1. In the next slide, I'll show you later. An electropolymerization of that can be achieved in the presence of perchloric acid from a 20 millimolar solution containing 0.1 molar tetrapropyl ammonium perchlorate in acetonitrile, keeping the potential at 1.2. So it's the oxidative polymerization. It's quite important to have this perchloric acid. It is needed to protonate the NH group, which prevents the attack by amine nitrogen lone pair on pyrrole radical cation. So without that perchloric acid, the cation radical, newly formed cation radical is destroyed by or reacted with the NH lone pair. And here is the cyclic voltogram of that one. The solution of the monomer, you can see it's nicely well defined. Cyclic voltogram is shown here. And the polymer, we get a slightly shifted, more difficult to reduced, and also easy to oxidize. It's reversible curve. And I've given you the conditions what we used here in acetonitrile, 0.1 tetrapropyl ammonium perchlorate, and the films were made use passing 4.58 microcoulombs at 1.2 volts. So the next one I can show you, we initiate freshly prepared film is showing a cyclic voltogram as such. It's difficult to reduce, but after few scans, it normal break-in pattern or the swelling of the freshly prepared polymer, it gives the expected cyclic voltogram. And I have given you the conditions used for that one. And in summary, I have given you a brief introduction to the pyrrole and polypyrrole derivatives, example of some of the literature values or the literature compounds, and some applications of polypyrrole derivatives and the synthesis of the target molecules. And as mentioned here, that compound is not very soluble in acetonitrile, so we couldn't do any work on that one. The compound 7 can be electropolymerized onto an electrode surface. And finally, thank you very much for your attention. I'm prepared to answer any questions if you have.
Thank you very much, Professor Pereira. And now the session is open for any questions. If the audience have any questions that you want to ask from Professor Pereira.
May I ask a very general question? Now you said your synthesized pyrrole compounds can be used as battery material. Two things: how harmful is it for humans, and the second thing, how costly is it compared to other battery materials available to synthesize?
Actually, synthetic perspective, they're probably more expensive, I think. This is actually, you can use chemical methods to polymerize, so you can get a powder of polypyrrole, but I don't think we can simply use polypyrrole or the cyanoacetylene polypyrrole for the battery material, because the synthesis of these compounds take a lot of money actually. It's expensive to make cyano compound. You can see how many steps we have gone. So polypyrrole material, probably they might be useful actually, but I haven't done any research in that. That is a literature work I just showed you.
Thank you, Professor.
So, Professor Pereira, if you use this for batteries, so which part you can utilize it for the cathode, anode, or for the electrolyte or anything like that?
Now, if you look at that, the polypyrrole, you can dope with iodine or something. It can oxidize to about 25%. So every 4 out of 1 pyrrole can be oxidized to make a cation, and then they will be compensating with the anion as well. So those charge things can probably be used as, shuttles for electron transfers. I honestly don't know whether you can use these material, but that is what the people say. There are application as battery material. Our major synthesis part is actually make the modifications to the electrode surface where we can have a higher environment or cyanoanthracene can be actually a reductive potential we have, and there you can be reduced some material in the solution and catalytically. But actually what we found, actually they are not quite stable. They tend to dimerize. When you have the two anthracene group, they make a dimer like that automatically stops the polymerization as well, because they are bulky molecules. When it forms dimers, that's why it's sudden drop of the reduction, and then it gradually oxidizes.
Okay, so that I have another one that is your material 8. So you said that it is difficult to dissolve in acetonitrile. So are there any other solvents that you can dissolve that?
Actually, it was eluted from a column, which is dichloromethane. Dichloromethane is not a good solvent for electrochemistry because it can be, involved in the radical anion and that may react with. Okay. So therefore, we found it's difficult dissolving this polar solvent acetonitrile. Acetonitrile you need because we have to go through the 2 volts to -2 volts in this particular case. So there are limited solvents available, and even that we will find again the same problem. The lone pair of the nitrogen can involved in the radical cation formation, right? So we didn't proceed after that because we know already difficult to dissolve, and then polymerizing with 2 bulky groups might not make a polymer as well.
Thank you very much. Are there any questions from anyone in the audience? So if there are no any further questions, I thank again Professor Pereira, and we will move to the next presentation. The second presentation of the session is effect of film thickness of reduced graphene oxide counter electrodes on photovoltaic properties of dye-sensitized solar cells. The authors are JMKW Kumari, MAKL Disanayaka, GKR Senadira, and Ms. Kumari will present.
I'm Kalpani Kumari from National Institute of Fundamental Studies, Kandy. Today my research topic is effect of film thickness of reduced graphene oxide count electrodes on photovoltaic properties of dye-sensitized solar cells. Introduction. Dye-sensitized solar cell is a promising alternative to conventional expensive silicon solar cells and a solution to global energy and environmental problems because of low cost, low toxicity, simple fabrication technique, and low light performance. However, enhancing the efficiency of the dye-sensitized solar cell still is an important issue. And there are 3 major components in dye-sensitized solar cells. Those are die-attached TiO2 semiconductor photoanode, electrolyte, and count electrode. Today, in this study, we are focused on count electrode part. The role of count electrode is catalyzing the reduction of the redox species in the electrolyte that used as a mediator in the regeneration of dyes after electron injection. Platinum is commonly used as count electrode due to its superior conductivity and high electrocatalytic activity. But there is a considerable attention on platinum count electrodes due to expensive and limited supply. Recently, carbon-based materials considered as candidates of count electrodes in DSSC applications And however, the preparation method of carbon-based count electrodes always associated with some problems, such as low adhesion to the conducting substrate, thereby low redox performances, and low charge transferability. In this study, we used reduced graphene oxide to prepare the count electrode by simple spray technique. And to investigate the effect of count electrode film thickness on the performance of DSSCs, a series of RGO count electrodes were prepared by varying the used RGO amount. Materials and methods. TiO2 photoanode preparation. Here we used a double layer structured TiO2 based photoanode. For the first layer, was prepared using P90 TiO2 powder. A paste was prepared by mixing P90 TiO2 powder with nitric acid, and this paste was spin coated on FTO glass substrate and sintered at 450 degrees for 45 minutes. For the second layer, a paste was prepared by mixing P25 TiO2 powder, nitric acid, PEG 2000 and Tridin X100. This paste was applied on top of the P90 TiO2 layer by Dr. Blade technique, and these were again sintered at 450 degrees Celsius for 45 minutes. After cooling, these were immersed in ruthenium N719 dye for 24 hours. The liquid electrolyte contains PMII ionic liquid, iodine, guanidinium thiocyanate, TBP in acetonitrile. These weighted chemicals were mixed and continuously stirred using a magnetic stirrer for about 12 hours. For the count electrode preparation, we used RGO, reduced graphene oxide powder, acetic acid, Tridin X100 and ethanol. Here we used different amounts of RGO from 5 milligrams to 20 milligrams to vary the thickness of the count electrode. All these chemicals were mixed and sonicated for about 1 hour and sprayed on pre-cleaned FTO glass substrate while heating at 100 degrees Celsius. And these sprayed FTO glass substrates were sintered at 250 degrees Celsius for 45 minutes. To fabricate the device, prepared liquid electrolyte was sandwiched in between die-attached TiO2 photoanode and RGO count electrode with the active cell area of 0.16 square centimeter. Characterization. We have done SEM characterization, XRD, Raman spectroscopy, current voltage measurements, and cyclic voltmeter measurements. When I move on to the results and discussion part, figure A showing the XRD patterns of the prepared RGO powder. Here, a broad peak of RGO was observed at 2 theta around 25 degrees, which corresponds to 002 plane, and a small peak was observed at 2 theta around 45 degrees, which corresponds to 100 plane of RGO. According to the Raman spectra of figure B, RGO exhibits two major bands. The first band is at 1354 per centimeter, that is D band, which is related to the defects and disorder in the hexagonal graphitic layers. And the second band is at 1591 per centimeter, that is G band, is related to the vibration of sp2 bonded carbon atoms. Here, the surface SEM image of prepared RGO count electrodes are showing with the different magnifications. These are exhibits of fluffy and wrinkled RGO with lot of stacking layers. And this figure showing the cross-section images of RGO count electrodes with varying thicknesses from 13.6 micrometer to 34.6 micrometer. However, it can be observed from these images that the film thickness is not much uniform due to the fluffy and wrinkled nature of RGO sheets. voltage characterization. Here the graph showed the current density voltage characteristic curves for fabricated devices. This proposed system of RGO count electrode was compared with the sputtered platinum plate as a count electrode for DSSC. All these photovoltaic performances of these DSSCs were summarized in the table. And according to the table and the graph, it can be observed that the platinum count electrode gives the best DSSC efficiency of 7.82% due to its excellent electrocatalytic and conducting properties. And DSSCs with RGO count electrodes using 15 milligram RGO gives the best efficiency of 4.7% with the film thickness of 27.7 micrometer compared to other thicknesses. These enhanced photovoltaic performances may mainly due to increase the surface area of the count electrode. Finally, the cyclic voltmetry measurements were obtained to investigate the electrochemical behaviors of the platinum and RGO count electrodes with the active area of 1 square centimeter. Here, the characteristic plots for each count electrodes were obtained using iodide-based liquid electrolyte with the scan rate of 50 millivolt per second. And the applied sweep potential is from -0.5 volt to 1.2 volt. Silver chloride electrode was used as a reference electrode, and platinum rod was used as count electrode. Here the prepared RGO count electrode and platinum count electrode is used as the working electrode. Here the peaks related to oxidation and reduction reactions were observed for both count electrodes, confirming the good electrocatalytic activity towards the redox reaction of the electrolyte. Conclusions. We have successfully fabricated RGO count electrodes by spray method for the applications in DSSCs. The simple and low-cost preparation method provides the formation of a porous structure with improved electrocatalytic activity for triiodide ion reduction at the count electrode. And the energy conversion efficiency of DSSC is improved with increasing the RGO film thickness, and the highest DSSC efficiency was obtained as 4.7% for the RGO count electrode with the film thickness of 27.7 micrometer. This may mainly due to increase the surface area. And this count electrode based DSSC showed the good stability and satisfactory performance compared to platinum count electrode based DSSCs with efficiency of 7.82% for the similar conditions. These results suggesting that this RGO based count electrode can be one of the alternative to the platinum count electrode in DSSCs with further modifications. I would like to acknowledge to the National Science Foundation for financial assistance. And these are some of my references. Thank you.
Thank you very much for your nice presentation. And now it is open for any questions. If audience have any questions, so you can raise it from the presenter. So I have one question. For the cell which you got the best performance, its RGO thickness is you have mentioned 27 point some micrometer value, no?
Yes,
so how much is your titanium dioxide film thickness?
It's the film thickness is around 12 micrometers for the TiO2 layer.
TiO2. So
Yes,
this is actually higher than the thickness of the titanium layer, no?
Yes, sir. Yes, sir. But the thing is, it's a kind of fluffy nature of the RGO sheet. So when we are taking the SEM images, it showing the high value maybe. When we are fabricating the device, it may be low.
They may be compressed.
Compressed, yes, sir.
Yeah. And one more thing that I have noticed is in your IV curves, when you compare it with the platinum electrode, so the I cannot remember either the series or shunt resistance. So because of that, the fill factor is not very good when you use this RGO counter electrodes, no?
Yes.
So
Yes,
have you
yes,
think about that addressing that particular problem to improve this?
Yes, sir. Yeah, this is ongoing research. Normally, when we are taking as only RGO, it is normally showing low fill factor due to the attachment, low attachment to the FTO glass substrate. So we are working on to improve that attachment. Thereby, we can improve the not only fill factor, the other parameters also, such as JC, VOC, and by hence efficiency also. This is the basic study. Yes.
Right, thank you very much. And are there any more questions from the audience? Since there is no any more questions, I thank the presenter once again. And we'll move to the next presentation. The third presentation is forecasting tourist arrival in Sri Lanka. The author is H.A.N. Tilakaratne, and it will be presented by H.A.N. Tilakaratne.
Hello everyone, I'm Nayam Tilakaratne from YMB University of Sri Lanka. I've done my research on forecasting tourist arrivals in Sri Lanka, and I'm going to present this based on the findings of my research. This is the content of my presentation. Introduction first, and the objectives of the study, results and discussion, and finally the conclusion. Okay, let us first get a rough idea of the tourism industry in Sri Lanka. Tourism is one of the most fast-growing industries in Sri Lanka, and it has been a popular tourist destination since ancient times due to its natural beauty. The government started the development of the tourism industry in 1937 when the Ceylon Tourist Bureau was established. However, due to the World War II, the tourism industry was closed down. After Sri Lanka regained independence, the government worked on promoting tourism in Sri Lanka by re-establishing the Ceylon Tourist Board. In October 2007, the Sri Lanka Tourist Board was replaced by the Sri Lanka Tourism Development Authority. We know that Sri Lanka is a country that is able to attract a lot of tourists. So what could be the reasons for this attraction? Nature spots, flora, climate, beaches, sports and adventure, botanical and zoological gardens, heritage, festivals, handicrafts, local and traditional food. They are some of the factors that attract tourists, and there are many more. As I mentioned earlier, Sri Lanka is a very popular tourist destination, and this country has several highlights in the world tourism industry. Now I'm going to talk about some highlights. Colombo City was the world's fastest growing tourist city in 2015. Yala National Park has the world's highest number of leopards per square kilometer. The world's largest gathering of wild Asian elephants is at Minneriya Park. Unawatuna Beach was named as the world's best beach for 2004. Most people considered the ancient stone fort Sigiriya as the 8th wonder of the world. Adams Peak is the mountain where people of 4 main religions worship together. Let us now find out what the objectives of the study are. There are 3 main objectives: analyze tourist arrivals by the country of residence, present a more accurate forecasting model of tourist arrivals, and forecast tourist arrivals and compare actual arrivals and forecasted arrivals for 2 years. Now, the most valuable part of this presentation, results and discussion. The Box-Jenkins methodology was used in this study. It consists of 4 steps: identification of the preliminary specification of the model, estimation of the parameters of the model, diagnostic checking of the model adequacy, and forecasting future realizations. The data was obtained from the annual reports of the Sri Lanka Tourism Development Authority, and annual arrivals between 2010 and 2017 were analyzed by the country of residence. Here I've considered 8 countries of residence: North America, Latin America and the Caribbean, Eastern Europe, Western Europe, Asia, Middle East, Africa and Australasia. The annual arrivals of countries of residence were analyzed to find out from which country of residence the highest number of arrivals occurred. Thus, it is clear that the highest number of tourists have come from Asian countries. Therefore, 11 Asian countries such as China, India, Indonesia, Japan, South Korea, Malaysia, Maldives, Pakistan, Philippines, Singapore, and Thailand were selected to monitor tourist arrivals. According to this chart, it is clear that almost every year, most arrivals were from India. So, monthly arrivals from India from 2010 to 2017 were selected to forecast arrivals. The Minitab software was used to build a time series model. By looking at this time series plot, it shows a trend pattern and a small seasonal variation. This is the autocorrelation function for the dataset, and it shows a trend pattern. That means this series is not stationary, and we need to perform a trend difference and consider the autocorrelation function for the difference series. Here, this is the autocorrelation function after difference the series. You can see it cuts off at non-seasonal leg 1 and seasonal leg 2. That means now the series is stationary. Since the series is stationary, now we can move to the partial autocorrelation function. This is the partial autocorrelation function, and you can see it cuts off at non-seasonal leg 1 and seasonal leg 1. Hence, we can say our tentative model is SARIMA 111102212. Here 12 is the seasonal leg. Now we are going to test parameters. Hypotheses are coefficient is 0 versus not so. By looking at the final estimates of parameter, we can see the p-value of AR1 term is greater than 0.05. That means AR1 term is not significant and we have to remove that. After removing that term, we can see all p-values of the parameters are less than 0.05. Now we can say all parameters are significant. Next, we need to check the randomness of residuals. Hypotheses are residuals are random versus not so. Here we can see p-value of leg 24 is less than 0.05. So we need to consider autocorrelation function and partial autocorrelation function for residuals. Here these are autocorrelation function and partial autocorrelation function for residuals. And we can say ACF and PACF are 0 in both seasonal and non-seasonal areas. So no need to add MA, SMA, AR or SAR terms. That means Now we can say residuals are random. Next, we are going to check the parameter redundancy. By looking at this correlation matrix, we can say there are no high correlation between any two parameters. That means there is no parameter redundancy. Here we check the normality of residuals. This plot shows a straight line. That means residuals follow the normal distribution. Now I selected 5 models based on the tentative model and calculated mean absolute percentage error MAPE and mean absolute deviation MAD values for each model. The last model, Sarima 011-10012, can be chosen as the best model to forecast tourist arrivals from India as it has minimal MAPE and MAD values. Using that model, I forecasted arrivals for 2 years and compared the forecast arrivals with the actual arrivals. Looking at the chart at the top, we see that in 2018 there is not much difference between the two lines. But the result in 2019 was quite different. The number of actual arrivals per month is less than the forecasted value. Here, residual mean square error of the forecasted period is 11,964.7756. Now is the time to present the conclusion of the study. This study was undertaken to forecast tourist arrivals from the country that produced the highest number of tourists to Sri Lanka between 2010 and 2017. It found that most arrivals were from Asian countries, and from among the selected 11 Asian countries, India indicated the greatest number of arrivals to Sri Lanka within the period from 2010 to 2017. According to the results obtained, Sarima 011-10012 is the best model to forecast tourist arrivals from India. In this study, forecasting was done for only 2 years, 2018 and 2019. The actual arrivals in the years 2018 and 2019 were compared with the forecasted value. This study will help to identify the strategies outlined in the Tourist Strategic Plan 2017 to 2020 that will affect the actual arrival and to look for reasons not to influence them with a better approach. Here are some of the references I studied regarding this area. And thank you all so much.
Thank you very much, Ms. Tilakaratna, for your nice presentation. And now the presentation is open for any questions.
Hello everyone, I'm Nayon Tilakaratna from YMB University of Sri Lanka. I've done my research on forecasting towards
it's playing
arrivals
again.
in Sri Lanka, and I'm going to present this based on the findings.
So if there are any questions, so
May I ask one question? Now, Naomi, was this, you had yearly data, monthly data, I cannot remember.
Sorry, ma'am?
Did you use yearly data or monthly data?
I used yearly data to find out which country had the most number of arrivals, and after that, I used the monthly data to forecast the arrivals.
Okay, even with monthly data, how many data values now? You have 7 years of data, right?
Yeah.
So I do not think that you should give your MAP values up to that many decimals that the computer provides. I mean, you had given it up to so many decimal values. And the second thing I noted is, of course, we should expect, 2019 is a different year. And even in your plot, I noticed that the actual arrivals were less. So it may be not because of your model, actually because of other incidents that has happened, right? So if you had, I'm not very convinced whether that year is a good data, I mean, good year to compare to see how good your model is. But rather, if you had left, if leaving out one more years of data and predicting for 2017, perhaps would have given you different results, I believe.
Yes, ma'am.
Any comment?
The study was done in 2017. That's why I forecasted values for next 2 years.
Yeah, I understand all that, but we like you could have you predicted without knowing this situation, right? That's what you are saying. This was done in 2017, even though you are presenting it now. That's what you are saying, right? Oh, okay.
Can I ask a question now? Although you mentioned we are going to predict these values and we have the situation different now, COVID and all that, you can check the backward, see whether your model work with the 2016 or 15 and all that. See whether there might be some correlation with those figures and we can justify those your model.
Yes.
Yeah, Professor Sarath, that's what we were saying. Yeah, what she had used is not a good point, no? In any case, you cannot report results after that many decimals. That's a mistake, I believe.
So are there any more questions? So if not, we can move to the next one. Okay, since there is no any questions, so we thank the presenter once again. And the next presentation is the substituent effect on the variation of photophysical properties of 1,10-phenolphthalein in the analysis of ferrous 2. The authors are MVT Mawela, WKDPS Kodituakku, MDP Ticosta, and R. Senthilnidhi. It will be presented by MVT Mawela.
Hello everyone. In this presentation, I will be briefly summarizing the research area regarding our abstract topic, which is the substituent effect on the variation of photophysical properties of 1,10-phenolphthalein in the analysis of Fe2+. 1,10-phenolphthalein. 1,10-phenolphthalein is the parent molecule of an important class of nitrogen heterocyclic, polycyclic, aromatic hydrocarbons which can act as a bidentate chelating ligand for transition metal ions. It has a very unique set of structural and chemical properties like planarity, aromaticity, rigidity, and basicity, in addition to it being a weakly fluorescent molecule. 5-5 electronic transition of 1,10-phenolphthalein majorly accounts for its fluorescent emission. This is polarized along the molecular plane of phenolphthalein skeleton along the X and Z axis. By altering the degree of electronic delocalization along these axes, the photophysical properties of pristine 1,10-phenolphthalein could be fine-tuned. Introduction of different functional groups to different atomic positions of the 1,10-phenolphthalein skeleton, the extent of electronic delocalization in the aromatic ring system could be changed. Chelation of Fe2+ with 1,10-phenolphthalein. Due to the strong chelating affinity of 1,10-phenolphthalein, especially for Fe2+ ions, it has the ability to form an octahedral metal ligand complex through chelation in 1:3 metal to ligand ratio. This complex is found to be non-fluorescent unlike free 1,10-phenanthroline molecule. Therefore, can be used as turn-off fluorescence sensor to accurately quantify trace amounts of Fe2+ in biological and environmental samples. The sensitivity and the selectivity of this parent probe molecule could be optimized by substituting different functional groups to the phenanthroline skeleton. In this study, we mainly focus on 1,10-phenanthroline and its epoxy and nitro derivatives, which are as given in this slide. So, this is the epoxy derivative and this is the nitro derivative. In order to understand the substituent effect on the photophysical properties of pristine 1,10-phenanthroline, to develop its detection, selectivity, and sensitivity, spectral investigations, temperature studies, and performance characteristic analysis were conducted under specific conditions as given in this slide. Results obtained are explained in the next few slides. Firstly, the spectral characteristics of the three probes were taken by obtaining their respective absorption and emission spectra. The study was conducted in methanol water 1:1 system at 25 Celsius. As it can be seen, the spectral peak maxima and the corresponding Stokes shift of the nitro and epoxy derivatives show a deviation from that of the parent 1,10-phenanthroline. The absorption peaks are resulted from 5 to 5 star photoexcitation, predominantly from singlet ground state to the first excited state. The prominent shoulder peak is observed in the absorption spectrum of 1,10-phenanthroline, which is not significantly observed in its two derivatives. This shoulder peak corresponds to the 5 to 5 star electronic transition of the singlet ground state to a higher singlet excited state, most likely the singlet second excited state. According to the Karsha's rule, the emission spectral peak maxima results from singlet first excited state to the singlet ground state. Thus, regardless of irradiation wavelength, only a single fluorescent emission peak is observed, which can be clearly seen in all three fluorescent emission spectra in this slide. The absorption emission peak maxima and the corresponding Stokes shifts of each probe molecule is summarized as given in this table. Regarding the nitro derivative, which contains an electron withdrawing group, a slight blue shift or hypsochromic shift is observed. Moreover, the epoxy derivative with an electron donating group shows a red or bathochromic spectral shift. By this, it is evident that the photophysical properties of the 1,10-phenanthroline Greek moiety has been altered through substitution. In the temperature study, the three fluorescent probes were quenching with known amounts of Fe2+, and according to Stern-Volmer equation given here, so this is the Stern-Volmer equation. The Stern-Volmer plots for each probe was constructed for different temperatures as shown in this slide. This table summarizes the variation of Stern-Volmer quenching constants with the temperature for 1,10-phenanthroline, nitro derivative and the epoxy derivative. It can be observed that with the increase of temperature, the Stern-Volmer quenching constant magnitude reduces for 1,10-phenanthroline and 5-nitro-1,10-phenanthroline. The opposite is observed for its epoxy derivative. With the increase of temperature, two things will occur. Weakly associated metal ligand complexes can dissociate, which result in reduction of static quenching in the ground state molecules as a result of high molecular vibrations with the rise of temperature. This can lead to a reduction in Stern-Volmer constant's magnitude. Simultaneously, due to the increased kinetic energy of molecules which leads to higher degree of molecular collisions, it can lead to increase of collisional or dynamic quenching. This can result in the increase of the Stern-Volmer quenching constant's magnitude. Thus, this is an indication that pristine 1,3-phenantholene and its nitro derivative predominantly show static quenching with Fe2+, while collisional quenching effect has overpowered the static quenching effect in the epoxy derivative. Therefore, collisional quenching is predominant in the epoxy derivative unlike the other two probes. This possibly is due to the structural difference of the epoxy probe compared to its parent and the nitro derivative. The determination of limit of detection and limit of quantification of 1,3-phenantholene and its derivatives in the analysis of Fe2+. Linear regression analysis was done to the Stern-Volmer plots of the three probes at 25 Celsius. The limit of detection and quantification were determined as summarized in the table given in this slide. It can be seen that in methanol water solvent system at laboratory temperature, the detection limits of both the nitro and epoxy derivatives are better than that of their parent 1,10-phenantholene molecule. Thus, it can be clearly seen that the sensitivity of the parent molecule could be improved by substituting different functional group and thereby fine-tuning the parent molecule's photophysical properties. To conclude, we can say that the fine-tuned and optimized fluorescent probe molecules, which are the nitro and epoxy derivatives used in this study, can be used to accurately quantify trace amounts of Fe2+ in biological and environmental samples. These are the two references that we use in the preparation of the abstract and the extended abstract. We would like to thank the Chemistry Department of the Open University of Sri Lanka for providing us the lab space, and we extend our gratitude to Professor M.D.P. Da Costa and Professor R. Senthilnithi for their supervision, guidance, and support. Thank you for your attention. Feel free to ask questions.
Thank you very much for the presentation. Now it is open for any questions.
I would like to give the presenting credit to Pooja Kodituaku, who is a co-author of the article. It is not Jayani Mawali, it has to be Pooja Kodituaku. Thank you.
So what kind of uses that you can have with this synthesized material? What are the uses?
Actually, both the epoxy and nitro has shown better detection limits and quantification limits in the determination of Fe2+ ions. And the specialty in fluorescence detection is that you can detect ultra small levels like trace quantities of Fe2+ in biological and environmental samples, and with a high sensitivity since we are using fluorescence to detect them. So that is the advantage of this rather than using a colorimetric method where the UV normal spectrometer uses the colorimetric properties are much less sensitive than fluorescence. Fluorescence is highly sensitive, so the detection limits are very low as a result of that.
Thank you. And one more thing. So are there any possibility of detecting this heavy metal ions like mercury and lead using the same material?
The specialty of phenanthrolene and its substituted compounds have a higher selectivity to Fe2 plus ions. We
Okay.
have found the interferences with other transition metal ions, which play like cobalt, nickel, copper. They show higher interferences with Fe2 plus, but the selectivity of Fe2 plus has a higher, it has a higher selectivity for phenanthrolene and its substituent than other transition metal ions.
Okay, thank you very much. So are there any more questions from the audience? So if there are no any more questions, so I would like to thank the presenter once again, and we'll move to the next presentation. The next presentation is high performance liquid chromatography DAD analysis of carotenoids present in saffron flower stigma. The authors are RMTN Pereira, JASU Gunawardana, UG Chandrika, and DDD H. Alvis. It will be presented by RMTN Pereira.
Our research study is about high-performance liquid chromatography DAD analysis of apocarotenoids present in the saffron flower stigmas. I'm going to present our research study under these contents. Among spices, saffron is valuable for deity. It is the stigmas of Crocus sativa flower. Apart from that, saffron is a traditional medicine, and it has known to show therapeutic significances like anti-cancer, antioxidant, and antidepressant activities. Carotenoids, monoterpene aldehyde, monoterpenes, and flavonoids are the major phytochemicals present in saffron stigmas. As you can see in the diagram, these are the bioactive secondary metabolites present in saffron. They are saffronal, picrocrosine, and apocarotenoids. As apocarotenoids, crosine and crozatine are present in saffron stigmas. Major apocarotenoids like crozine are the derivatives of dicarboxylic acid, crozatine. For our study, we are mainly concentrated on crozine and crozatine. Crozines have similar conjugated hydrocarbon structure, and they form different types of crozines by attaching different sugar moieties to its terminal ends. So the structures given here are the 5 types of crozines. These bulky sugar moieties make crozines unusually water-soluble when comparing to the other carotenoids, which are only lipid-soluble. Acid hydrolysis of these crozines give a common product, crozatine. The presence of conjugated polyene system allows molecule to absorb visible light, which in turn gives the compound its color. Relationship between chrome-4 and light absorption properties are used in identification and quantification of saffron carotenoids. The characteristic shape of the UV visible absorption spectrum is due to the allowed S0 to S2 electronic transition, where lambda max value corresponds to 0 to 1 vibrational transition. Now, let's move to the objective of our research study, which is identification and characterization of different apocarotenoids present in commercially available saffron stigmas by using spectroscopic and chromatographic methods. This is our methodology. As the first step, we extracted the carotenoids present in saffron stigmas using following steps. First, we ground the saffron stigmas into a powder and extract the carotenoids using absolute ethanol. Then the extract sample was concentrated using rotary evaporator. After that, the sample was dried by purging nitrogen, and it was stored at -20 Celsius. As the second step of our methodology, we acid hydrolyze a saffron extract to obtain crozatine by using following steps. First, we hydrolyze the extracted crosines from the saffron sample using 1M hydrochloric acid and centrifuge the sample. And then we wash the precipitate with distilled water. After that, the sample was dried by purging nitrogen, and it was stored at -20 Celsius. For the characterization process, we used the UV visible spectrophotometer and high-performance liquid chromatography with photodiode array detector. For the UV visible spectrum of carotenoids, we observed the absorbance of sample in the range of wavelength from 190 nanometers to 700 nanometers. In HPLC, as for the mobile phase, we used acetonitrile and water as a gradient elution. A C18 column was used as the stationary phase, and the sample was run under the flow rate of 0.5 microliters per minute for 60 minutes. So, this is the UV visible spectrum which was given by the saffron stigma extract. Crosine was identified by using following factors: spectral fine structure, lambda max value, which equals to 433 nanometers, and the 3/2 value. According to the spectral data, crosine was identified as the major apocarotenoid present in commercial saffron stigmas. In addition to crosine, sample contains picrocrosine and safranal, which appears in 200 to 400 nanometer region. This is the spectrum which is relevant to the sample obtained after acid hydrolyzing the saffron extract. In here also, crosine was identified using following factors: spectral fine structure, lambda max value, which equals to 425 nanometers, and the 3/2 value. Using the spectral data, it was concluded that crosine is the major apocarotenoid present in the sample after the acid hydrolyzed of the saffron extract. This is the HPLC chromatogram of crosine. HPLC analysis was done at 440 nanometers. According to the chromatogram, 5 types of crosines were detected by the saffron sample. Here, those 5 types of crosines are shown by the peaks labeled as 1, 2, 3, 4, and 5. Among these 5 types, probably the major peaks 1 and 2 are C3 and C2 crosines respectively. As you can see in the structures, crosine 3, which contains gentioboyacil sugar moiety in one end, and crosine 2, which is also known as tricrosine, contain gentioboyacil in one end and glucosyl in other end, can be the major crosine types present in our saffron sample. This is the HPLC chromatogram of crosatine. An HPLC analysis was done at 440 nanometers. After the acid hydrolyzed, only one prominent peak was observed in the chromatogram. Therefore, we were able to identify only the crosatine after the acid hydrolysis of all the 5 types of crosines. Therefore, it was confirmed that 100% pure crosatine can be obtained by the acid hydrolysis of crosine. Now let's move to the conclusions of our research study. According to the spectral data, we concluded that saffron stigmas contain crosine, picrocrosine, and safranal. And also we concluded that 5 types of crosines are present in the commercial saffron stigma sample. Finally, we concluded that 100% pure crosatine can be obtained by the acid hydrolysis of crosine. These are our references. We would like to express our special thanks to the head and staff members of the Department of Chemistry of Open University of Sri Lanka for giving us this valuable opportunity. And also, we wish to extend our gratitude to the members of the OUSL Chemistry Research Laboratory and to the research funding by the Open University of Sri Lanka. Thank you.
Thank you very much for your nice presentation. And now it is open for any questions. So if you have any questions, you can ask them from the presenter. So have you done this as your undergraduate project or for aiming some other degree?
So we have done this under our undergraduate people.
Undergraduate. It's a nice work actually.
Thank you, sir.
So what are you targeting for this kind of research?
We actually done this. We have some other works to do on this ongoing research. Our main focus is to study about the quercetin as a dye synthesizer for solar cells.
Okay. So have you done any investigation of their durability, whether they are strong enough when you expose them into sunlight? And
we are studying about on that.
so do anyone in the audience have any questions to ask from the presenter? So we have time. I think she has completed it less than 10 minutes, so we have even 4 minutes left to start the next one. So if there are no any more questions, so we thank the presenter once again. Thank you very much for your nice presentation, and we can move to the next one. So the next presentation is stellar populations and structural properties of 6 ultra-faint dwarf galaxies. And the authors are B.K.S. Pereira, J.V. Wijesekara, P.L.V.J. Sigera, K.S. Ratnayaka, H.R.S. Udani, W.C.S. Senarath, H.M. K.G.A. Herath, K.A.C. Nilmini, A.M.C.I. Abhiratna, P.V.N.D. Vimalavira, B.B. Ashen Chaturanga. And the paper will be presented by B.K.S. Pereira. Over to you.
Hello everyone, I am Krishna Pereira from the Institute of Astronomy Sri Lanka. Today I am presenting our research titled as Stellar Populations and Structural Properties of 6 ultra-faint dwarf galaxies. Here are the contents of this presentation I am going to present you. And our objectives are to calculate some general properties such as age, metallicities, and abundance of alpha elements of selected 6 ultra-faint dwarf galaxies in the Milky Way, to compare these values with a globular cluster as a reference, and to show that metallicities of the UFT galaxies were found to be extremely low, and it reveals that the UFTs are composed of all stellar populations. One of our major quests in astrophysics is the understanding about the formation of structure of our universe. For an instant, even dark matter simulations predict around 500 dwarf satellites in our Milky Way alone. There are only few dwarfs have been observed in the local group. First of all, I'll introduce you few major terms that may useful in understanding this work. First, a dwarf galaxy is a very small type of galaxy with low luminosities. In contrast, ultra-faint dwarfs have extremely low brightness surfaces as their name implies. They are the oldest, most metal-poor and darkest matter-dominated stellar systems ever known. In snapshot, I would like to express in this way. Consider this giant galaxy with 100 billions of stars. If this is like a large city, like France, for an example, a classical dwarf galaxy can be introduced as a theater in this city, which can be hold only thousands of people. Then an UFT is similar to one person in this theater. Most of these dwarf galaxies are satellite galaxies, which are orbiting a large host galaxy such as the Milky Way or Andromeda galaxy. In this research, we observed about 6 UFTs. They are Como Berenices, Boots 1, Ursa Major 1, Hercules, Canis Venatici 2, and Leo 4. Also, we used one globular cluster named as NGC 2808 as a reference to compare with these 6 UFDs. A globular cluster is a densely packed collection of ancient stars. During the stellar evolution, which happened billions of years ago, all the stars of these dwarf galaxies or globular clusters have been formed at the same time. Hence, all the stars are at the same distance and they have similar ages and chemical compositions. We generate color magnitude diagrams to observe several properties of these UFDs and the globular cluster. Color magnitude diagram or CMD is a diagram which is drawn with absolute magnitude with respect to the color index. Here we observe ages, metallicities, and the abundance of alpha element values for each of these stellar objects. Now let's move to the methodology part. We calibrated data to plot our CMDs obtained from deep optical images using these shown filters on the advanced camera for surveys. After the CMDs were plotted, these shown groups were observed, and also we derived the values of age, distance, and reddening provided the best fit between isochrones by using these equations. We generated a relevant Python code to derive its CMD. Before generating CMD, we created isochrones by using Dartmouth Stellar Evolution Program or DSEP. Since our main focus areas were age, metallicities, and abundance of alpha elements, we estimated these values by using DSEP. Also, we assumed that the alpha abundance as 0.4, which is an appropriate value for old metal populations, metal poor populations, which are in galactic halo. Here we go to the results and discussion section. The 6 UFTs studied using Hubble Space Telescope photometry had nearly same metallicities as shown here. In contrast, the globular cluster NGC 2808 has a metallicity value of -1.24, which is comparatively larger than the other UFDs. We plotted all these CMDs according to two values as shown here. There we plotted for y equal 0.33 and y equal 0.245 plus 1.54z. For an example, y equal 0.33 indicates that it possesses a 33% abundance of helium. Ages of 6 ultrafine dots were 14.8 gigayears in Coma Berenices, 13.8 gigayears in Booth 1, etc. According to these values, it's obvious that all the 6 UFDs are in around similar or same age. Here figure 1 represents the CMD of each UFD. These tend to be very similar to each other. It means that the population, ages and metallicities are also similar. This graph is presenting the CMD of globular cluster NGC 2808. The red clump here further clarify the metallicity abundance of globular clusters. A red clump is a clustering of red giants in the HR diagram. Generally, red clumps have more metallicities, so NGC 2808 has a metallicity value of -1.24, which is comparatively higher than all the 6 UFDs we observed here. In general, a star's main sequence turn-off point is the point on the HR diagram where the star evolves from its hydrogen burning phase into its next stage. In all 6 CMDs of UFDs, this main sequence turn-off is less than -0.5, which implies that they are in the older populations. Here is the conclusion of our research. We can conclude here that the metallicities of the UFD galaxies were found to be extremely low. These extremely metal-poor stars in these UFDs were considered to have been the first-born stars created in the universe. Also, CMDs of 6 UFDs looks very similar, meaning that the population, ages and metallicities are also very similar. These dim satellites are older than 10 gigayears in contrast to brighter dwarf spheroids. They all show extremely low metallicity distributions, nearly as low as that of the Milky Way's stellar halo. Finally, it was demonstrated that UFDs are composed of all stellar populations. According to the calculations based on the cold dark matter concept, the local group contains more UFDs than previously detected. The end of the session. So here are the references that we used in this research. I would like to thank all these authors in these research papers and this website. We would like to express our gratitude to the Institute of Astronomy Sri Lanka for providing us this opportunity. Thank you very much.
Thank you very much, Krishni, for your nice presentation. And now it is open for any questions. So I have one question. This is not regarding the subject matter. has it run in the correct way? Because I noticed that in some places it is just like jumping from one slide to another. Has it done correctly?
Sorry, I didn't get you.
The presentation went on correctly, because I noticed in some places it is just jumping from very quickly.
So yeah, it was a technical issue that when passing into the next slide, there was something like I couldn't fix on it.
Okay.
It's on originally on this PowerPoint recording. Several times I tried, but I couldn't fix that problem.
So have you collected this data by your observation, or have you got them from some website?
Yes, the data was we got from Hubble Space Telescope. Normally we can get these with data, but when we draw in the graphs, we used separately brought the Python code, and then by using then we draw CMGs. Before that, we put this data into Dartmouth. It's a software for this kind of like analyzing. So there we manually we entered the data and we got isochrones first, and then with that Python code we draw these graphs. Data was collected from not collected means like Hubble space, because it's very difficult to collect ourselves data, but we can get them from some other resources like Hubble Space, Europe, Southern Observatory, like that.
Okay. Anybody else have any questions? So if not, we thank the authors and the presenter once again, and we can move to the next presentation.
Thank you very much.
The next presentation is relationship of sunspot number with crop yield for selected crops in different countries, a mathematical approach. The authors are VAC Hansani, APH Somaratna, DP Ranasinghe, AT Bulatsinhala, KAC Nilmini, JV Vijayasekara, RKCS Ranatunga, HRS Udani, BKS Pereira, WCS Senarat. And it will be presented by VAC Hansani. Over to you, Hansani.
Hello everyone, good day. I am Chamali Vidana Rache from Institute of Astronomy, Sri Lanka. Our topic is relationship of the sunspot number with crop yield for selected crops in different countries. We are going to discuss these topics within this presentation. Food is one of the most important and essential human needs. With the increment of population, food has become a limited thing, and therefore agricultural intervention have focused on increasing food production to reduce malnutrition, hunger and poverty. So, agricultural development plays a key role when it comes to the topic of ensuring food security. To overcome this matter, agricultural crop production should be more focused. Since the effect of the weather conditions has been identified as a key factor that could affect yield, we have studied the effect of solar activity on crop production. Solar activity has a direct effect on weather conditions. Climatic parameters depends on the output of the sun in the forms of electromagnetic radiation, energetic particles, and changes that occur in the magnetic field. And in terms of solar activity, what we have considered here is the sunspot number, that is a key indicator of solar activity. The solar cycle is an approximately 11-year cycle experienced by the sun. The sun's stormy behavior builds to a maximum and its magnetic field reverses. Then the sun settles back down to a minimum before another cycle begins. Sunspots are the areas where the magnetic field is about 2,500 times stronger than Earth's and much higher than anywhere else on the sun. What you all can see here is a solar cycle of 11 years. And we are in the 25th solar cycle, which was started in 2019, and it will last until 2030. It will come to its maximum on July 2025. In a previous study done by us, which was published in Uva University Research Sessions held on 1st July 2021, a modeled equation was developed to predict the yield of some selected crops in Sri Lanka. Tea, rice, and sugarcane was selected for this study considering their economical and sociological importance. Two more crops, namely soybean and banana, were selected for this study considering their growth in the selected countries. Our main objective of this study is to investigate the validity of the proposed crop yield model against sunspot number in latitudinally different countries, thereby stress the importance of accounting sunspot number in the conventional weather parameter when predicting crop yields across the globe. Data on the total cultivated area with yields of rice, tea, and sugarcane was obtained from United Nations Food and Agriculture Organization, and online data on the yearly mean total sunspot number from 1961 to 2019 was retrieved from Sunspot Index and Long-Term Solar Observatory section of World Data Center. The crop yield model was used to investigate the relationship between crop yields against sunspot number for selected crops. And multiple linear regression was used in this study, which best represented the relationship between solar activity and crop yield variables to predict the yields of crops in Sri Lanka. And the analysis yielded parametric coefficients, and those were inputted into the following modeled equation for each study of the crops. And the validity of the crop yield model against the sunspot number created for Sri Lanka was applied for different countries throughout the world as well. We have considered three main regions on the globe when selecting countries for this study: on equator, near equator, and high latitude countries. You can see the countries that have been selected for each category for this study, and the climate effects were ignored in the selection of countries. Banana, soybean, and tea that grows in the selected countries were analyzed to investigate the predicted yield of different countries on the selected regions. And the coefficient of determination, or square value, was used to evaluate the efficiency of the model. According to the preliminary studies, a significant decrease in the crop yields were observed during solar maximum in the years of 1968, 1989, and 2000, while an increase in crop yield was observed during solar minimum in the years of 1976, 1996, and 2008. And the table indicates the calculated R-squared values for the crops grown in the countries of the selected regions of the globe. The coefficient of determination, which means R-square values, were greater than 0.82 for tea, 0.88 for banana, and 0.67 for soybean. It ranges from 0.0 to 1.0, with higher value indicating a better agreement. and the model performed considerably well for all the countries worldwide. According to the model developed by us, we could plot these graphs of actual and predicted yield against time. The first graph shows the actual and predicted yield for tea in Argentina with a p-value of 0.61. The second graph shows actual and predicted yield for tea in India with a p-value of 0.74. The third graph shows the actual and predicted yield for soybean in the USA with a p-value of 0.18. And the fourth graph shows the actual and predicted yield for soybean in Indonesia with a p-value of 0.63. The fifth graph shows actual and predicted yield for banana in China with p-value of 0.07, while the sixth graph shows the actual and predicted yield for banana in South Africa with p-value of 0.23. For the selected food crops and regions throughout the world, the validation results were within this range, and hence the model can be seen to be robust against the sunspot number on latitudinally different countries. The model could be satisfactorily employed in the assessment of impacts of an adaptations to climate variability due to solar activity and sunspot. Furthermore, these results revealed the validity of this model. The R-square values obtained from the multiple linear regression fluctuates between 0.67 to 0.96, and the p-values obtained for Sri Lanka and other countries under this study were greater than 0.05 level of significance for every crop considered. So it concludes that the model performed considerably well for the countries under study for the selected crops. So it is obvious that there is an effect of sunspot number on crop yield similarly to other parameters that affects crops. And a model using a polynomial regression analysis can be a better representation for different crops in other countries, and further studies of this are currently underway. So these are the references that we have used during this study. And as authors, we all would like to extend our gratitude towards the Institute of Astronomy Sri Lanka for providing facilities for us to conduct this research. And thank you all.
Thank you very much for your presentation. And now it is open for any questions. So I have one simple question. So when this activity is very high, why do we see it as a black spot? This activity high areas?
Those areas can be seen as black color, but the areas actually cool areas. Very low temperatures there, so we can see black color compared to those other areas.
But in those areas the activity is high, no? Is that so?
Yes, sir. Yes, sir.
Actually, it is happened because of the magnetic field fluctuations. That areas.
So according to your results, what you finally say is when the activity is low, you get a higher yield, no? That's as I could understand. Is that correct?
Yes, sir.
So why do you think it happened so? What may be the reason?
It happens because of the sun's activity.
It's happened because?
Because of the sun's activity.
Yeah.
Different energy level.
So normally the yield goes up. So actually the crops produce more food because of this photosynthesis process, no? So when we are getting low light, low intensity, when the activity is low, so they will produce higher yield. So are we getting low level of sunshine when this activity is low? Or electromagnetic radiation?
Electromagnetic radiation.
Yeah, even more sun, like if really less sun cycles mean, sometimes it could be change the world climate also. I think once long before ago, there was some called little ice age kind of situation even in northern and southern hemispheres. So sometimes maybe it's effect to this photosynthesis process, because more sunlight, more sunspot means something it's related with the magnetic field. So it could affect this some processes on the earth.
So are there any effects to the weather, this sunspot? And
yes, sometimes it could be, because these days also it says that this solar cycles has increased. So it could affect many ways, even sometimes maybe for the communication system on Earth, weather, and if it really gets worse. So it all the processes like with the suns, because these are, especially when we go study about the atmosphere of sun and the activities, it related with some of work effects on our Earth.
but anyway, you have not considered those weather effects in your calculation, no? So are there any more questions from the audience? So if not, I would like to thank all the authors in this presentation and the presenter in the usual way. And so we are coming to the end of the session. I think it is a very fruitful research session with presentations in diverse areas of physical sciences that we had. And I would like to take this opportunity to thank the presenters and the authors, all of them, for their interest in publishing their research work in Hours 2021. And at the same time, I would like to thank Dr. WCW Navaratna, who is the team convener, and she is the one who handle all these things, sending your presentations for reviewing and all other things. Also the session person, chairperson, Engineer Ranjit Priyanka, and Mr. Charit Sirivardhana, who is behind us technically assisting us playing these videos. And before winding up, I thank the audience also who actively participated. And thank you everyone for your support to make this session a success. So that we will end the session now, and have a nice evening, all of you.
Thank you, Professor Susira, for chairing the session, and all the presenters for sharing their work at the Open University Research Sessions. And as Professor Susira mentioned, I need to thank Engineer Rajit Priyanka, and also, of course, behind the scene, Mr. Charit Sirivardhana, who played the videos right on time. Thank you very much. I appreciate your support. Thank you.
Thank you very much, all. Thank you very much.